I want every one of you to be very clear. What is big data and how this big data is connected to the term called Hadoop. Whenever you hear the term called big data, parallelly, you also hear the term called Hadoop. Definitely there exists some relationship between these two. If you might have taken my demo or at least gone through the demo recording, by this time you might be definitely clear what is big data and how this big data is connected to Hadoop. In connection to that, probably we take Himani. Himani, you can unmute yourself and yeah, Himani, you're available? Yeah, that's fine. Sunil?
Yeah, Srinivas, I'm there.
No, no, not you, Sunil. Sunil Mortha.
Yes, Srinivas.
Yeah, yeah. So I would like to hear from your end. What is big data and how this big data is connected to the term called Hadoop?
Uh, I have to go. I have to go through the videos, Srinivas. Really, I didn't look at the demos. So
Okay.
at this point, I'll not be able to say anything.
I appreciate, That's where I would like to get the feedback. Then only see, presuming that everybody of you know what is big data, and I move forward, then definitely it is going to impact your learning process, right? So, Arvind,
Yeah,
yeah,
that's true. But I had to travel to India and I couldn't go through the videos. So
no issue, Arvind, no issue, Sunil. I understand. Yeah, Arvind,
Yes, sir. Yes, sir. Good morning.
yeah, very good morning, Arvind. So I would like to know what is big data and how this is connected to Hadoop.
Yeah, any data which is been stored and in order to process that huge amount of data, so it is really a challenge. In order to store as well as process the huge amount of data, this big data has come into the picture. And Hadoop is related to the processing as well as the storage.
Okay,
So this is
I appreciate. See, that is the reason why, say, you are being asked about how you define a good citizen. Say, you are being asked how you define a good citizen. How you define a good citizen. Same like what I am saying here, what is big data? I'm saying how you define a good citizen. Probably you'll start coming out with your own answer saying, follow rules and laws, be honest and trustworthy, be compassionate, be a good neighbor, protect the environment. All these are the ways to be a good citizen. Same you see what London newspaper is going to say about be a helpful person, be a friendly person, be a kind person, be a person who achieves all this, and you will be valued as a good citizen. So if a term like this good citizen is being mentioned and asked you to define it or say something about it, everyone starts coming out with their own views, and you get hundreds thousands of views towards what a good citizen, then definitely we are confused, and the scope of this one becomes huge. It will not be confined. Same is a story even with your same is a story even with your big data, the term called big data. So there is one other thing, that when you fail to understand or define something on its own, it's always a good practice that you divide and try to conquer. Divide and rule is proved to be one of the best techniques all the times. This is not the rule that is invented a day back or a year back or 10 years back. This is a rule being followed by the entire British Empire to conquer the world. You try to understand what is data first. Try to understand what is data first in its true meaning. Then you try to add big to that. You will be able to understand clearly what is big data. Then we try to understand what is Hadoop. Then we try to establish the relationship that exists between these two. And that's the best way all the times. So to make this happen, I would like to share this slide. Hope everyone able to see my screen. If you look at this one closely, you understand. Data at the very lowest level. When this data is being processed or churned or synthesized, we get information. And when information is further synthesized, we get knowledge. With knowledge, we gain wisdom. With wisdom only, we make decisions, either good or bad. Based on your decisions only, the future of the organization depends. So before we try to understand what is data, I want to bring it to your notice clearly why data is so important. When we identify data is so important, because just before we identified, we have understood, let us understand data first. And once we understand data, then we'll think about big data. That is what the conclusion we made. As a part of that, we are trying to understand what is data basically. And before we try to understand what is data, we are forming a conclusion why data is so important. If we conclude data is really important, then we think about what is data. If that is not important, we can ignore it. That is why we are establishing a rule now. Yes, data is important, not just important, data is crucial. Directly or indirectly, the future of the organization depends on the data. Imagine no data, there will not be information. Without information, we cannot acquire knowledge. Without knowledge, we cannot gain wisdom. Without wisdom, we cannot make any decision. If you are not able to make any decision, the future of the organization is in dark. So this slide gives you the understanding data is very, very important and crucial to any organization, irrespective of the size. This is what we technically call it to be DIKW model: data, information, knowledge, and wisdom. Data, information, knowledge, and wisdom. DIKW model: data, information, knowledge, and wisdom. Data forms the base with which we acquire wisdom. With wisdom only we make the right or wrong decisions, based on which the future of the organization depends. So this made very clear to us data is very, very important. And now, when we have understood data is so important, nothing wrong to understand what is data. Data is raw, unorganized facts that need to be processed. Data is raw, unorganized facts that needs to be processed. When the same data is processed or organized or structured or presented in a given context, we call that to be information. When data is processed or organized, structured, presented in a given context, it becomes information. Each student's test score is one piece of data. Each student's test score is one piece of data. The class average score or the school average score is considered to be the information. Because with each student's test score, I will not be able to do anything. With each student's test score, I will not be able to do anything. But with the class average score or the school average score, I can make a decision. Maybe we do a lot of other things before making a decision. But with the class average score or the school average score, which is more meaningful than just a student's test score, I can do many things as a class teacher or as a class or as a school principal. The class average score or the school average score makes more sense to me. Hope you have understood very clearly why data is so important. We have understood. And what is data? We have understood. To the same data, if you are able to add big, this slide gives you data handling. If you see, we get the data always from the real world. We never get the data from the imaginary world. Even if we get the data from the imaginary world, it cannot be used as a base for any fruitful implementations. We to have some predictions or presumptions, we may use it, but we always consider and work with the data coming from the real world. With certain rules and regulations, you process the data, you get the information. When that is modeled, you get the knowledge. When that is defined in terms of a goal, we get wisdom. And with wisdom, you attach the values that becomes a vision to the organization. Look at the stack. DIKW model. So this made very clear to us data is very, very important, essential, crucial to any organization, irrespective of the size. I don't know whether you are following this anytime or not. In the contemporary world, companies are being evaluated. Usually, when you are evaluating a company, we only look at the assets. If it is a manufacturing company, we look at the resources, we look at the number of years of the existence, we look at the margins, I mean the profits, what they're making each year. We take these parameters into consideration before we evaluate the company. But today, along with all these physical, data also became a, a very important factor in deciding the valuation of any organization, how much data you're holding. You just take Facebook as an example. The true net worth of Facebook is based on the, I mean, apart from the infrastructure and all, that all is a different. That's not the major. How Facebook is been evaluated is based on the amount of data they are holding with them about you, me, or spending patterns, our social movements. See, in the coming days, I mean, not coming days, even today, our life is completely public. There is no private. You are moving with your gadgets. You are being tracked. Where you are going, how much time you are spending, where you are spending. So that is what the true net worth of Facebook today. So that definitely makes you to understand how much important the data is. It's very, very important, very crucial in defining the future of any organization or the valuation of any organization. So if the same data is being equipped with three essential characteristics like volume, variety, and velocity, it takes the shape called big data. The term big, what it means, what we mean by big. Huge volume, wide varieties, and a quicker ability of processing the data. So big data is anything which has got three essential characteristics: volume, variety, and velocity. These are the three essential characteristics with which we define something called big data. What are those? We have volume, we have variety, and we have velocity. These are the three essential characteristics with which we define something called big data. So you are being asked anytime what do you mean by big data? Big data is anything which has got three essential characteristics. Essential, I mean must. In addition to these volume, variety, and velocity, We have other V's coming up: value, viscosity, and you have veracity. So these V's are getting extended from time to time to make it more robust and complete. Along with the volume, variety, and velocity, we have other threes like value, viscosity, veracity, and all. So these V's are getting extended, but these are the three core V's with which we define something called big data. Now coming to the volume, how this element called volume is going to influence you or impact you. Have a look at this one. Compared to the books what you have in your shelf, these are more in volume. Is a clear indication or understanding. Volume is never absolute. Volume is never absolute. It is always a relative term. Compared to the books what you have in your shelf, I have more. Compared to the books what I have in my shelf, someone else might be having more. So this is what I say relativity. What do we mean by more? There is no definition to that called more, right? So volume is anything that is specific to this one, what is been observed. Which defines in relation with something. Maybe absolute value we can have, but we cannot say absolute volume. So only when we reach this volume, it is considered to be big volume. No. Volume is a term which is always by comparison. You may ask me what is the impact of this volume. Before we move on, let me share with you how data is actually being measured. 8 bits put together 1 byte, and such 1024 bytes put together 1 KB, and such 1024 KBs put together 1 MB, such 1024 MBs put together 1 GB, then terabyte, then petabyte, exabyte, zettabyte. Anyone knows about what is beyond zettabyte? What is beyond zettabyte?
Your Hello, sir. It is yottabyte.
So beyond zettabyte is 1024 zettabytes put together 1 yottabyte. So you may ask me one thing, what is the impact of this volume? If you look at this slide, you understand and appreciate the amount of data that is coming into your box every day. Into your box, I mean into your server. You as an organization, the amount of data that is coming into your box, I mean into your server, every day. Imagine I am getting 1 GB of data per day. The business I am in generating 1 GB of data per day. Quite natural and a common thing, even at the grassroots level. 1 GB of data per day. But the ability to process this 1 GB of data is not there with me. I can only process 800 MB of data. The remaining Um, so 1024, that is 224. The remaining 224 MB of data I was not able to process because of the infrastructure, whatever I have. With my current infrastructure, I am capable of processing only 800 MB of data. Beyond 800 MB, I will not be able to process. So every day, 224 MB of data is being left over. That is what I am trying to share with you here. The amount of data coming into the organization is growing up with the upward graph. The downward graph is showing you the ability to process the data is coming down day by day. As a result, you will get a blind zone. Why we call that as a blind zone? For the reason, what is there inside that we don't know. Whether it is good or bad or useful or useless, I don't know till I process the data. Only when I process the data, I come to know whether that is a useful data or a useless data. Till then, I should feel there is very valuable stuff inside it. That is what I mean by till then, till you process the data, you should consider there is gold inside it. You come to know it is gold or useless only when you are able to process the data. So big data volume, the term volume under big data is throwing me a challenge where you store huge volume of data. Even you store huge volume of data, how you are going to process the data so that we will be able to get the meaningful insights of what the data we are producing. So volume is throwing me a challenge when the volume of the data grows beyond. When the volume of the data grows beyond, how you manage that? How you manage that basically? Let us not worry. Same when it comes to the second we called variety. Second we called variety. I think you are able to understand here. Variety, you have something called variety. So I am trying my best to show you here what I mean by variety. There are hundreds, thousands of varieties. The question is how all these varieties of data can be stored. Because you take your traditional RDBMS, you define a schema, and as part of that you have tables, and again each table has got a specific structure, and you put the data into this as expected. At the time of retrieval, you get as expected. But you try to keep the data which is not suitable for this storage, it immediately says, I cannot store this data. So that is why those are all technically called as schema first. Schema first. We define the schema, I mean the definition first, and then start pushing the data. There is a very big advantage with that. The big advantage is you know what you are storing, you definitely will come to know what you are going to retrieve. But may not be applicable for every context or case. So the question is, like your traditional RDBMS, is it going to allow you to store only pre-identified data types or data, because that is a straightforward and fair enough aspect, that yes, what is being defined there, the same is being used to store, no problem. But when it comes to the real world, we are getting the data from weather sensors, we are getting the data from different sensors, IoTs, I mean, Internet of Things, when they are being connected to different sources, they start emitting the data. All that, if you see closely, data is organized into semi-structured, unstructured, and third one is structured. For this, absolutely no problem. We have the RDBMS where we store the data, and whenever you want, you retrieve and you work with it. But when it comes to semi and unstructured data, that's where the big challenge is. So how you can accommodate your semi and unstructured data, semi and unstructured data. So till now we have observed volume is going to throw a challenge to me, where and how we store, how and where we store this huge data. And your variety is going to throw a challenge, how you store these wide varieties of data. How you store these wide varieties of data, because if you see alone in the image, you have RAR, MPEG, JPEG, GIF, and all. Sorry. In the media again, you have MPEG, AVI, WMV, WMA, WAVE, MP3, MP4. So alone in the media, each category you take, how many varieties of data you have. Most of them are public and few of them are proprietary. Only those people or those organizations can use them. And if you need to use, we need to have prior permissions to get their tools and start working with the data. So you look at this one closely, again it is theory of relativity. Compared to the number of varieties of data somebody knows, I may have more number with me. So these two are throwing me the challenges. How you store huge volume of data and where you store wide varieties of data. So my storage should not put a constraint saying, oh, I allow only these two types of data to be, I allow only these two types of data to be stored. No, it should not say that. Like how your hard disk is not putting a constraint on you, let you bring any data, it is able to accommodate that on your hard drive. Down the line, whether you retain the data or you throw it away, that is different. But whatever the data that comes to you, if you try to store it on your laptop hard drive, it never puts a constraint. So I want a storage in such a way that there should not be any constraint. I allow only this kind of data to be stored. It should say, let the data be anything, I should be able to store that one. And then comes is your velocity. So looking at this slide, you should definitely get the understanding. Data is coming from different sources, weather sources, into my weather server. And I need to process that one and emit the results to my end users. Though it is a routine example I gave, but it has got more meaning to the context. That is why I share that example only. You are back from office, you are relaxing, you switched on the TV, someone reading the news on the screen saying Yesterday there was heavy rain in the city. Does that make any sense? We already experienced it. We already enjoyed it. So there is no need for someone to say that yesterday there was heavy rain. It makes sense that the newsreader is reading tomorrow morning 10 to 11 there is a possibility of heavy downpour in these parts of city, so that we can make the necessary precautions. You take the necessary precautions, or you postpone your travel to those parts of city. If it is mandatory, we take enough care before we go out. Suppose the data that is coming into the box, if it takes more than 24 hours to process that and give the results, then you will come to know about the information only when the disaster has happened. So velocity is something that is related to how quick you are able to process the data, how quick, fast, efficiently you process data is what the velocity indicates. Velocity is nothing but the rate at which the data is coming into your box, what we call it to be velocity. Now tell me, looking at all these 3 points, what you have understood. Looking at all these 3 points, what you have understood. We've got 3 points now. What are those 3 points? Volume and variety. You look closely these two things. These are throwing a challenge to you or to me about storage, where you store huge volume of data, how you store wide varieties of data, both related to storage only. And the third one, velocity, that is related to your processing. We need to have a good technique with which you are able to process data so fast without any time lag, so that you can drive or derive or share meaningful information to the end user. You look at these three things closely, they are throwing me two problems. How you store huge volume of data, and how you store wide varieties of data, and how quickly you process the data. So these things, if you look closely here, throwing me as a challenge. What your big data is throwing now? Just now we have observed big data is of these three. Big data is anything which has got volume, variety, and velocity. That's it. Definition is over. Things which are easy to use or easy to enjoy, and they are very complex in the background. So volume and variety are linked up with your storage, and velocity is linked up with your processing. But all these things you see, storage and processing, no doubt, even today, using your NAS boxes, various forms, you are going to store your data. And if you are able to index that one properly, even you are inside a huge data store, still you are able to pick your required things. So you look at this one, you understand storage and processing are the two problems which are being thrown by big data. How and where you store huge volume and varieties of data, how you can accomplish processing the data so fast. So for that sake only, you got Hadoop, where one side we have storage, other side we have processing. This is achieved through your HDFS, and this is achieved through your MapRed. So the very term Hadoop implicitly means core. So when I use a term called Hadoop, I implicitly mean HDFS. That is nothing but Hadoop distributed file system. Hadoop distributed file system is a linear scalable architecture, linear scalable. Even if your data is exponentially growing, still your HDFS is not going to say thrash all your existing infra and set up this one. Even working with Hadoop over a period of time, when the data goes beyond some manageable limit, you keep on expanding your resources, data is going to travel with you. Hope you understand what I'm trying to share here. So your HDFS is a file system, no doubt, but a distributed file system specific to Hadoop, with which you are able to store any volume of data and any variety of data. With which you are going to store any volume of data and any variety of data can be stored using your HDFS. And then comes is your MapReduce programming model, with which you are going to crush any kind of data in the best possible, because your MapReduce is going to make use of massive parallel processing in the background. As a result, let your 1 TB of data, it can be crushed in 5 minutes of time, or 10 TB of data, it can be it can be processed in almost the same 5 minutes of time. Even if it is 20 GB or 20 TB of data, the same story. Because a MapReduce in the background is going to make use of massive parallel processing, that technique with which you are able to process data so fast. So now I ask you, what is big data and what relationship exists between big data and Hadoop? So I discussed more than 40 minutes now about this. So I would like to hear from your end. What is big data and how it is connected to the term called Hadoop? Yeah, friends, I want your opinions. What you mean by big data and how that is connected to Hadoop? Yeah, friends.
Big data is like how you
Can you be a bit loud, Sunil? Sachin, I think, right? Sachin, yeah, not audible
no,
to.
this is Sunil.
Yeah, Sunil, go ahead.
Is it clear?
Yeah, it's clear now. It's clear now.
So big data is like how you process a huge number of data in a faster way. That is, I mean, simple meaning of big data. And Hadoop is which helps us to process the data accordingly.
Okay, appreciate, appreciate. Murthy, yeah,
So, hi. I
yeah,
don't
Murthy.
want to repeat the same words you did it in the last. To me, big data is a problem statement, and
Yeah,
Hadoop is the solution for it.
wonderful, wonderful, wonderful.
And Hadoop is not a technology or any science. Hadoop is just a two word, which is storage and mapr. Mapr is used for processing, and storage is with the distributed file system, which will address the storage problems.
Absolutely, that's really cool. So if you look closely into the discussion what I made, most of the times what people think is big data is a kind of a platform or technology or language or a solution, something like that they think. Big data is basically, it is a problem statement. What is a problem statement here? What is a problem statement here?
Sorry, I want
How
to ask you.
and where you store huge volume and wide varieties of data. How and where you store huge volume and wide varieties of data is what your big data is questioning you. Your big data is also questioning you how you are going to process this huge volume of data effectively or efficiently. It's not that you process the data and you start giving the results after 6 months. By the time the disaster has already happened. So big data is no doubt a problem statement. To this problem statement, there is an open source solution called Hadoop. This is an open source solution. Open source solution. It is not a proprietary solution. It is an open source solution. So what is the best part here? Can be used by anyone without any cost incurred to that. So Hadoop is an open source solution with which you are going to solve the problem called big data. How your huge volume and wide varieties of data can be addressed using your HDFS called as Hadoop distributed file system. Hadoop distributed file system. That is what we mean by HDFS. Don't worry, friends. I'm going to talk very in detail about Hadoop distributed file system and how we came to that level. What is file system? From that level we discuss. Maybe it takes one session, but until unless you understand clearly what is a file system, you will not be able to understand storage at all. If you are not able to understand storage, processing we can never understand. Because any programming language you take till date, any programming language you take till date, the central theme of any programming language is to store, retrieve, and manipulate the very important thing called data. And for that sake only you write the program. In order to write this program only you require a language, your programming language. Simple. Store, retrieve, and manipulate. Maybe you store only one time and all the remaining times you retrieve and very rare you manipulate. That is possible. Let the ratios or contributions be different, but store, retrieve, and manipulate is the essential goal of any programming. Even when it comes to this one. So storage is done using your HDFS, which needs to be clear to us first. Then only we can think about MapReduce, the processing model. So processing comes into picture only when you successfully store it. Without you successfully storing it, there is no point you processing that one. Right? So that is why even as part of our learning process, we work with HDFS thoroughly, and then only we move on to the processing part, that is your MapReduce. Any questions so far, friends? So this is only an intro session to make you to understand some basics and get the feel of that. So the actual discussion will be on the Hadoop part by talking about the file system. See, by talking about the file system, how it is going to be and all. We talk about those things in detail. So don't worry for that. So before that, I want you to clearly understand how big data is not a technology, not a platform, not a framework, not anything of this sort. Big data basically is a problem statement. Is a problem statement surrounding volume, variety, and velocity. And your Hadoop is an open source solution for that problem called big data. Yes.
If we consider Yeah, I want to ask you something. If we are considering velocity,
Yeah.
and by the distributed file system, it shows that you are chopping off the data into different files, right? So how can it not affect to the speed? Because if it is a large volume, then you can get a speed. But if it is a smaller volume, you are not compromising with the speed.
So speed in terms of processing, you're saying?
Yeah, processing and responding the
I,
answer to the question,
yes, I
means
appreciate. I appreciate.
whatever the user has asked.
Yeah. Say, for example, this is a piece of the work that needs to be done. This is a piece of work that needs to be done. If you deploy one person to execute this piece of work, he may take 4 days. If the same piece of work is given to 4 people, in how much time they can do it?
One day.
Same work is given to 40 people, in how much time they can do it?
Within few hours.
The same work, if it is been given to 4,000 people, in how much time it can be delivered?
Yeah, it is about distributing, but how about collecting?
Let me finish that. So, if you give to 4,000 people, then managing 4,000 people and first of all, assigning to 4,000 people, collecting the output from each, and then summarize it finally is going to become a big challenge. So, this gives you the understanding that when you're doing it linearly or sequentially, it is expensive. What we are doing here, one piece of work by one person, beginning till end, in a sequential mode, definitely it is expensive. So when 4 people are doing it parallelly, then it is going to be more efficient. 40 people, much more efficient. Keeping that thing in the mind, you bring 40,000 people, then it takes more than 10 days to finish the same job. Hope you understand what I'm trying to share with you here. By,
Yeah,
by making your processing to happen parallelly on multiple machines, which I'm going to show you here. See this one? Instead of me storing all the data at one place, I cut the data into small pieces and store it on different nodes so that processing also will happen on the same nodes where my storage is been done, right? So as a result, what happens? My 1 TB of file is divided into uniform blocks of 64 MB and stored into multiple machines. So tomorrow when I need to process my 1 TB of file, what I do? I will not bring the entire 1 TB to one place. Instead, I push my code to all the places where my data is present and start processing the data. So my data processing is going to happen parallelly within the node. You are seeing this as a cluster. Say for example, inside a particular node, see here, I have a data node 1. Don't worry about the technical terms and all. Imagine a cluster, well associated or well connected systems together to achieve a specific goal. So in my node 1, I kept 4 blocks. I kept 4 blocks. You can see that here. In my node 1, I kept 4 blocks. Okay. And node 2, I kept another 10 blocks, all of uniform size. So what happens with my processing is, my processing is going to be like this. On node 1, this is my actual data, and this is been sliced now. This one, exists on this node, on this one. On one more machine, I have another. For the same data set or for the same file, and one more node we have. Now what happens with MapReduce is, these 4 blocks are going to be processed parallelly by 4 different JVMs. This is JVM 1 to process this data, JVM 1, 2, 3 and 4. So within the node there is a parallelism. Within the node there is a parallelism. 4 blocks are getting processed same point of time. When my processing is happening on node 1, processing also will happen at node 2 and processing will also happen at node 3. So within the node there is a parallelism. Across the nodes also there is a parallelism. This is called parallelism inside parallelism, which they technically call it as, what is that? Massive parallel processing. Massive parallel processing. I hope Sachin, you have understood what I am trying to share with you here.
Yeah, I understood. But what is JVM?
It's a place where your Java virtual machine is a place where your Java code is going to run.
Okay.
So don't worry. Don't worry. If you are coming from non-computing background or non-programming background, then we see some basics of Java even, and then we talk.
Okay.
So
Okay.
within MapReduce is nothing but the job that you develop, that job, we send it to all the places where my data is located. So my processing is going to happen at a massive scale parallelly at the different levels. So my getting my results is going to be quite easier. Of course, there are challenges while collecting the data, because when I process the first block, I get some output. Second block, I get some other output. Third block, some other output. Fourth block. Now all these outputs need to be clubbed together. And from here also we get again. From here also we get again. And finally, this entire thing needs to be converted to. Are you able to understand, friends? Sachin?
Yeah, I understood it.
So that is why we are calling this as massive parallelism. Massive parallelism. Massive parallel processing, because there is a parallelism inside parallelism. That is what we call it to be massive parallelism, right? So your big data is just a problem statement. It is not a solution. It is not a platform. It is not a technology. It is not any of these. Big data is a problem statement. For that sake, there is an open source solution called Hadoop uh, in the form of HDFS and MapReduce. You may ask me one thing: why Hadoop has got HDFS and MapReduce? Because my big data is throwing me two problems: one storage and the other one processing. To address my storage need, I use HDFS. To address my processing need, I use my MapReduce. So whenever I use the term called Hadoop, I implicitly should know it is a combination of both storage and processing, not just storage. That is what the beauty part of your Hadoop. Most solutions either can provide you storage facility or can provide you processing facility. But this is the one which provides you both storage and processing facilities. And looking at this one, now everyone starts, uh, adopting that one into their organizations. Make sense, friends? Any questions to me? See, I don't want to overload you, taking too many things in one single shot and confuse you. That is not my intention in time. I want all the sessions to be very interactive and knowledgeable And end of the session, you should gain, yes, Srinivas, we have learned quite interesting things today. If that kind of feel is not there, then there is no point taking the sessions. So I want every one of you to be interactive. John, Himani, appreciable, John. Yeah. So you have any questions, please unmute yourself and discuss, or whenever you want to give some answer, then also you can unmute and discuss. Himani? Himani, you are there? I think you're on mute. That's fine. So probably by the time we meet, I advise you to just go through the basic thing on what exactly we mean by big data and what we mean by Hadoop. What we mean by, yeah, Himani, yeah, please. Are you able to listen to me? Am I audible? I think the microphone, any problem with the microphone? You might be speaking, but it's not audible to me. So as part of my big data, I have these components. You can see those. First, at the very lowest level storage, as I told you, until and unless I store, I'll not be able to do anything. So storage at the very lowest level, and on the top we have data processing, and on the top we have data access, and on the top we have data management, and finally your data analytics. So as part of our course, we are going to see data storage, data processing, data access, and data management. All we see data storage, where we see HDFS, data processing, MapReduce, data access, Hive, Pig, Scoop, and all we see, data management, Uzi, Flume, Zookeeper. But interesting, this time we want to see even data analytics, at least one or two tools to make you to understand how your process data can be well utilized in terms of analytics. That makes the complete stack. All these batches we never used to do data analytics, but now we thought of doing data analytics. Of course, we did data analytics, but ad hoc analytics using Hive, but we want to do professional analytics using Tableau or ClickView. A session or two, we want to do it even on data analytics so that you understand how your data, how your process data as a Hadooper or as a Hadoop engineer, how your process data is going to be used by the data analyst. You'll come to know that one. So this is what we call it to be Hadoop ecosystem. Hadoop ecosystem. I hope.
I have a question here.
Yeah, please, Sachin.
Yeah, cloud storage, HBase, are those part of Hadoop Hadoop system, or they are something else in the data storage?
No, your storage could be either HDFS or it could be simple storage service from Amazon. It is called S3. That could be HBase. That could be Cloud Store. All these are more or less the similar techniques from different vendors. That's the only thing. From different.
And the same framework works. I- Same frameworks like Hive and Pig works on those as well. Or does they only works on at DFS only?
No. See, even you take Amazon. I don't know whether you observed this anytime or not. You have S3. What is being shown there, right?
Hmm.
So S3 is actually a simple storage service from Amazon. S3 is called simple storage service. That is what I mean by yes, yes, yes. That is called S3.
Mm-hmm.
So this is a storage technique what Amazon is going to use. On that, you make your MapReduce to run, you make your pig hive and all run. You set up and you run it. Okay. And it is not mandatory that on every storage you need to have a pig hive running. Because if you take HBase, on HBase, I will be able to run my MapReduce framework to process my data. So that process is over there. Okay. The thing is, HBase, HDFS, S3, NFS with Mapr, Cloud Store, all these are the storage techniques which are linear scalable. Linear scalable, I mean, your need increases, you need not thrash the existing infrastructure. You can scale up your existing infrastructure. Say, for example, with Yahoo, as of today, a 12,000 node, observe 12,000 node live Hadoop cluster running even today. Still it is growing. That is called linear scalability. Okay. So these techniques, whatever you are seeing here, all runs on the same fundamentals, ground principles. But on the top of that storage, are we going to set up pig and hive to process the data, or are we going to set up a MapReduce alone, or some other, depends on their need and their requirement. But it's not mandatory every time.
Okay.
But
I got it.
storage is going to have more or less the similar techniques. What techniques? Fault tolerant. In the event of one node failure, still the data needs to be made available. Linear scalable. On demand, I can make things to work. I mean, if I want my storage to be increased from 10 TB to 20 TB to 100 TB to 500 TB to 1 petabyte, 10 petabytes, 100 petabytes, keep on increasing my storage. So for that sake, let me use any of these techniques, they are sufficient. But on the top of that storage, what I use to process depends on the specific need. Make sense, Sachin?
Yeah, I got it.
So I advise you to go through this one, friends. That is what I thought of sharing with you for today. Like what is big data and what is Hadoop and how these two are connected. As part of the Hadoop ecosystem, what other components we have apart from HDFS and MapReduce, I just thought of bringing it to your notice so that we go in detail. This is only the introduction. You see here all the components. It has become a customary practice that almost all the components of the tools, they are associated with one animal, and that is the reason why we also has got a component called zookeeper. Like how a zookeeper plays the role, same like even here is a coordinator system. How the zookeeper is going to establish the coordination between all the animals inside the zoo, same like even here all the components that you have, how they can be put together and establish the coordination between all, where we have a component called zookeeper even here, right? So we also has got the components like horse represents TechyBees, hive, pig, and hue, and we have hive. We have other components like mahout, will, and you have something called chukwa. So all these components are a part of your ecosystem, and it's not mandatory that everyone needs to be expert in every component. That's not possible even. So, but these things, whatever you are seeing here, We talk about HDFS, we talk about MapReduce, Hive, Pig, Scoop, and in the management you have Uzi, Flume, and Zookeeper. Those components we are going to see. And with these components, you can work in any Hadoop ecosystem as a data engineer. And that's what the ultimate goal, right? So you have any questions to me, friends? Please feel free to discuss so that I understand where you are and what your expectations are and how things needs to be delivered. Yeah, one after the other, friends.